In this module, I demonstrate the calculation of the time to double an initial investment. This is a time value of money technique, and I'll be using a financial calculator in the emulator mode. The calculator in this case is the Texas Instruments BA2 Plus. Sometimes it's essential to find the time it takes to double an initial investment. You can always start with an initial investment of $1. And so we already know that the future value of the dollar should be $2. In this particular example, the annual interest rate is 20%. So given this particular information that we have the interest rate as 20% and an initial investment of $1 and we want its future value to be $2, how much time will it take for that to happen? This is a straightforward application of this compounding formulation, which is future value equals present value times 1 plus interest rate to the power n, where n is the time it takes, it's a compounding period. $2 equals a dollar, which is the present value, times 1 plus 0.2. 0.2 is from 20% to the power n. This can also be written as 1.2 to the power n, which is 2 divided by 1. Here's the 1 and here's the 2. That's 2. This also comes from an application of simple algorithms, where if y is equal to x to the power n, so y equals x to the power n, so that's 2 equals x to the power n. If you take the natural logarithm of both sides, it's n natural log 1.2 equals natural log of 2. Now in this calculator you can see the natural log of 2 is 0.69. Oops. The natural log of 2 is 0.69 right here. In fact, on the PowerPoint slide is 0.693, so some of you may wonder how you can display the output to 3 decimals. What you do is you hit the second button and go to Format, which is behind the decimal key, and you see DEC equals 2. You can change it to 3 or 4 or 5 or 34 in this case, as much as you wish to, and we definitely don't want 34 decimals. So you go back here. In fact, don't want 3, actually want 3. So decimal equals 3, and then it's prompting you to hit enter. So you hit enter and your decimal is 3. You can clear the screen. So let's try it again. 2 natural log, and it's 0.693, which is what we have. Natural log 1.2, you can check it out, will be 0.182, and so the result is 3.8. So basically in this case we have that the time will take for an initial investment to double is 3.8 years, of course at 20%. That was the foundations of that. You can calculate the time it takes using this calculator much faster without having to do this algebraic calculation here. How would we do that? These are the time value of money keys: number of years, interest per period, present value, the payment per period, and the future value. This is the output n equals 3.8, and that's why it's written below the n key. So that is our solution. So we're not going to enter 3.8. The interest rate per year is 20%. So it's 20, and do IY here. Remember not to hit the IY button first and then 20. You hit the value first and then the corresponding function key. PV is -1. Why is it -1? Because that's how the calculator knows that that is an initial cash outflow or an investment, which is not a bad thing. So typically minus is sort of considered negative literally, but here it's actually an investment. It's a cash outflow. So you don't use this minus, you use this plus minus toggle key here, -1, and that's your present value. Your payment, which is basically a fixed sum of money, equal installments, is 0 in this case because you start with the initial sum of money, and after a certain period we want to see how much it would be. So payment is 0. And future value we know is 2. So we start with $1 and end with $2. For those of you, you can actually use, if you're wondering, you can use any amount. You could use $121 as your initial investment, and so you do 121 negative as your PV, and then your future value would be 121 times 2. That would be $242. So now that we have all of this, we have FV, PMT, PV, IY. All we need is N, which is the number of periods it'll take for this to actually become reality. So now we do something slightly different. We use the CPT, which stands for compute N, and you get 3.802. If you go back to the previous slide, you'll actually see our answer was 3.8, which was an application of the fundamental algebraic equation behind that. So this was a simple illustration of how you can use your calculator to actually find out the time it takes for an investment to actually double. In fact, you didn't actually have to have the final amount as twice. You could have it as any amount, 4.2, 5.2, 40, anything else. For those of you who do calculations using Excel, Excel has a built-in function called NPER, N-P-E-R, and it has 4 arguments: rate, payment, present value, and future value. Of course, in Excel, you have to enter the rate as a decimal. So in Excel, you use 0.2 instead of 20%, and that's your interest rate. Your payment is 0, present value -1, future value 2, and you get 3.8. The next part of this tutorial is about finding the interest rate. How would you find the interest rate if you're given an initial amount, you're given the final amount, and you also know the number of periods of compounding? So if we apply the basic formulation, FV equals PV times 1 plus I to the power n. 2 is your final amount, 1 is your initial investment, 1 plus I to the power 3, because you have 3 time periods, 1, 2, and 3. After solving this basic setup, you'll get I equals 0.2599, which is 25.99. So that's the basic setup, but we can do this using the calculator. You hit the on off button, and here actually are the keys here. So n equals 3, present value is -1, payment is 0, and future value is 2. Hit compute IY, and that's 25.99%. So you can double your money in 3 years if the interest rate per year is 25.99%. That's basically what this problem is about. This concludes this module, which covered 2 topics: finding the time it takes for an initial investment to double, and also finding the interest rate if you are given the number of time periods that were applied to an initial investment, and if you knew what the final investment was. This is Pank Agrawal, PhD Finance, giving you a tutorial on this topic.